Hello there, and welcome to Decision Models Demos. Today we're going to be looking at simulation of an ETF plus put portfolio, and we'll be working with the same file we worked with in class during block 1, ch06x, etc., cb0.xls, which, as you know, is up on Angel, and the example we'll be working through is also seen in the class book on pages 253 to 271. Okay, so here's the model that we will be working with, and again, the basic idea of this model is, given a return of the SPY ETF, some return, any return, let's say 0% return, we want our little Excel machine here to compute for us a return of a portfolio of one share of the spiders and one put covering one share of the spiders. And that's down here in G10, and you can see if the spiders have a return of 0%, our portfolio will have a return of minus 1.3%. And the reason for that is because we had to pay some extra money to buy the put, and that's degrading our performance a little bit. I also want to keep track of here what is going on with the SPY returns. So I've asked the Excel machine to just spit back out for us the SPY return itself. So the contents of G11 are just equal to the contents of G8. So if we have a 20% return for the spiders, you see we have a 14.5% return for our portfolio of one spider and one put. And if we have a return of minus 20%, for the spiders, our portfolio return is still floored. It's got a floor there at minus 1.3%. Okay, so let's see if we can get our simulation model set up. Of course, you want to make sure that you've got your model tab set to be on, so you see the solver options and model specifications dialog box over here. And the first thing that we need to do before running a simulation is to set up our options. So we go to the Options tab on the ribbon and choose All Options. And we're going to do this problem as we did in class with 2,000 trials. And so I set that to 2,000, simulations to run 1. We need to set our simulation random seed to 1, and that ensures that we all get the exact same answer. And the only other thing I want to change here in options is I want to change all trials to base case. So we have trials per simulation 2,000, simulation random seed 1, value to display base case. And when I've got those three things set, I say OK. And now also it's a good idea to check down here in the window to make sure that the trials per simulation of 2,000 took, which it did. So that makes me very happy. Okay, so now we're ready to tell RiskSolver platform which cell we want it to consider as normally distributed with expected value 2% and standard deviation 8%. And that's cell G8. So we go to Distributions, Common, Normal, with ourselves located in cell G8, and we tell it that the expected value for this normal distribution is in cell E4, and the standard deviation for this normal distribution is in E5. And once I've got that, I go up here to the Save and Close icon and click that. And notice what's happened now to the contents of cell G8. If we look up here at the contents of the cell, we see that it says equal PSI normal, etc. This is what tells RiskSolver platform that we want it to treat the contents of this cell, G8, as normally distributed with expected value 2%, standard deviation 8%. And now what I need to do is I need to tell RiskSolver platform what outputs I want it to follow as it's going to run through 2,000 trials for us. And I want it to follow what's going on in G10, which is our portfolio return, and what's going on in G11, which is our check on just the return of the spider. So I'll highlight both of those cells. Then I go up here to results on the ribbon, and I drop that down, and I want output in cell. And I just click that. And now again, you see the contents of both of these cells, G10 and G11, has changed. And the program has added these function calls plus PSI output to each cell. And that's what tells RiskSolver platform that we want it to record what's going on in these cells when it changes the contents of G8 2,000 times. Okay, so what we want RiskSolver to do now is to, in fact, change the contents of this cell 2,000 times such that the contents that go in there look as close to a normal distribution as possible, given that we only have 2,000 samples. And then we'll see what the corresponding frequency distribution of our portfolio looks like. Okay, so the next step to do that is to go up here. We're ready to simulate now. So we go to Simulate, Run Once, and that's very disappointing. It looks like nothing's happened, but wait, there's more. That's not quite true. If we just double-click on G10, we see this new window comes up with all kinds of information about what's been happening in cell G10. First thing we see is a frequency distribution, and I know this looks weird, but it's actually, it looks pretty good to me. What this is telling me is clearly our modal value is about minus 1.3%, the most frequently occurring value, and there's nothing below that. And to the scale of this graph, we can't see it, but there are, in fact, instances of returns up here, positive returns. We'll be able to prove to ourselves that this is true by looking at the statistics. And if we look at the statistics for what's going on in this cell, we see that the expected value return of our portfolio is 1.1%. That's degraded from our 2% return of the spider's only portfolio. And again, we should expect that because we have to pay for the put. So that's like paying for insurance. It's going to reduce our average return. And down here we see the modal value, the most frequently occurring value, is minus 1.3%. And also, that's become our minimum value. So buying this put insurance has put a hard floor under our losses. We can't lose more than 1.3% in any given month. And you can see here we still have some fairly significant upside. The maximum, we have to be very careful about this maximum because the maximum return is still unbounded. So this 24.3% has no special meaning, except to say that we are getting still some pretty reasonably high returns on very rare occasions. So this is looking pretty good to me. And now the next thing I want to do is I want to ask the question from a technical perspective, what is wrong with this model? Is it doing something stupid? Have I done something stupid to make it do something stupid? And one good way to check that is I thought I was telling Risk Solver Platform that what's in G8 is normally distributed with expected value 2%, standard deviation 8%, and I wanted it to change the value of that cell 2,000 times to make a histogram that would look as close as possible to that normal distribution. And so if that's true, that's what I should see down here, because I've told it the contents of G11 are exactly the same as G8. So let's double click on this and look at that frequency distribution. It's nice and symmetric. It looks unbounded. It looks like it's centered around 2%, although we can check this more carefully. And that gives me warm, fuzzy feelings. That's sort of telling me that the model is doing what it's supposed to do. So let's look at the statistics. Expected value 2%, middle value also 2%. That's great. Standard deviation 8%. So it's looking to me like we've done a pretty good job here of approximating a normal distribution with 2,000 trials. And we'll talk about what also is, of course, very important in models like this, or any model, is what qualitatively is wrong or right with this model, and how might it not be representing the reality that I'm expecting it to mimic. And we'll get to that discussion a bit more in Block 2. But for now, that's all we got, and I look forward to seeing you soon in Block 2.